Thanks, Ray. I'm happy to say I'm not going to say the word megafauna once in this talk, which will be a good change. So what we want to present to you in the next, hopefully in the next half hour, I want to try to be short because hopefully we can maybe have a discussion after, hopefully my somewhat brief talk, on this idea that Chris and I have kind of been tossing around for about 2 years now, and that is kind of revolves around trying to think about potentially new solutions to fisheries bycatch, and mainly in the role of can indirect mitigation work for fisheries bycatch. Mainly, we've been concentrating on seabirds. We're also now in the next year or two going to be expanding that to sea turtles and fishery bycatch. So this is what I hope to cover in the next 30 or 40 minutes. I'm just going to talk briefly about bycatch because I'm sure most of you are aware about bycatch and its issues, about marine biodiversity policy, and what we see as kind of perhaps a little larger holistic approach to the problem, and then talk to you about an example that we've been working over for the past year, and then talk about invasive species eradication, which I'm guessing you guys probably know a little less about than bycatch, and then the opportunities and challenges. So we all know that fisheries are important. They're big bucks. They're worth over $82 billion. They employ a lot of people, and they provide a lot of food. And we all know on the flip side of that is it has a lot of impacts. And along with the issue of overharvesting, which I'm not going to talk about at all today, there's this issue of bycatch, which is impacting a lot of species, including seabirds and sea turtles, and it's clear that it's also having ecosystem impacts. And so that can be summed up in the sense that the social and economic importance of fisheries combined with the biological realities of overfishing and bycatch result in cardinal tensions over ocean resources. And that often comes at a cost, recently in a cost in terms of lawsuits and closures, such as the Hawaiian swordfish fishery being shut down in the early 2000s and again shut down last year because of turtle bycatch. And that's pretty much the same story all over the world, at least with internet fisheries that are regulated. We see the same situation in New Zealand and Australia, where fisheries are increasingly getting shut down by not making seabird or sea turtle bycatch quotas. The good news is that agencies and organizations are starting to deal and grapple with the issue of bycatch, and that includes Australia, here in the U.S. with NOAA coming up with plans and trying to get their head around the issue of bycatch. And even better news, that in some cases, low-cost at-vessel fishing modifications and gear modifications are working for some species. And these include things like torii poles, night setting, weighted lines, circle hooks, etc. And of course, those mitigations come at some cost, and that includes financial costs both for fishermen and the agencies in terms of opportunity and operational costs. If fishermen are constrained at setting only at night or using weighted lines, and if there's any associated safety issues with those weighted lines. And it also comes at a certain political cost in the terms of lawsuits, contentious management, etc. And of course, it's even more complicated than that, because in a lot of systems, the solutions are much more difficult. And we're going to be talking mainly about the Australian eastern tuna and billfish fishery, which is coming under increasingly more and more regulations. So the gear modifications put on by the Australian government seems to be working well for seabird species such as albatross. They're not working well for endangered species of the flesh-footed shearwater, which turns out to have multiplicative effects because the shearwaters can dive deeper than the albatross. They hit the hooks, they float up, and that actually has add-on effects of catching albatross. So this fishery is facing new regulations and new bycatch limits, which are set at less than 0.05 birds per 1,000 hook, and right now they're averaging greater than 0.5 birds per 1,000 hooks. So they're facing a closure, and people in Australia are anticipating a potential closure of the fishery. And so there clearly would probably be not only financial loss and additional administrative costs, but also expenditure of some amount of political capital. So if we step back and look at seabirds in general and think about designing a sound marine biodiversity management plan or policy, we think about these issues. One, it has to be effective. You have to actually achieve the desired conservation outcome. It has to be adoptable. In the sense that it has to be not only economically viable, but also technologically feasible. It has to be enforceable in the sense of compliance. And it has to be sustainable in that you have to be able to actually implement the program on the ground, or in this case, on the oceans. So we stepped back and we kind of looked at this more holistically in terms of, if you look at an endangered seabird, there's actually a portfolio of mortality threats. So there's a suite of threats and consequently potential interventions that have variable costs and variable benefits. And what we're really interested in is a population growth rate that's either stable or increasing at the end of the day. And of course, we have to have habitat that sustains that species over the long haul. So a fundamental question that revolves around this approach is, well, how large an increase in lambda, or the population growth rate, you get per dollar, per conservation dollar invested? So then we said, well, what are the threats? If you look at the IUCN data for seabirds globally, and that's really the only best data set we have to work with, you see that this is the percentage of each of these major threats that contribute to all listed IUCN seabirds on the red data list. Invasive species is the greatest threat overall to endangered seabirds compared to habitat destruction, fisheries, pollution, and climate. Most money and press and attention is often concentrated on fisheries, pollution, and disease, as opposed to invasive species and habitat destruction. But what this data highlights is that seabirds in general face these land-based threats, such as coastal development on breeding islands, as well as invasive species, the main ones being rats and cats. And then they also face threats at sea, which is largely fisheries bycatch and also, to a lesser extent, actual human harvesting. So that's fundamental to what we're going to be talking about today, because we're dealing basically with two different systems. So this is the approach we took. That is, we wanted to identify the entire mortality portfolio across the life cycle of the species. We wanted to estimate the relative magnitude of those different mortality sources, and then try to estimate the revenue generated from those mortality sources, and then calculate a cost effectiveness of each potential intervention. And then, if possible, think about, can we figure out how to transfer capital from revenue generating mortality sources to fund conservation interventions for other mortality sources that are either revenue neutral or revenue negative, but might have a higher conservation return. That is, have a higher increase in the population growth rate per dollar invested, which is basically compensatory mitigation. So that's what we've done for this species right here, called the flesh-footed shearwater, which I mentioned earlier. Most of the world's population breeds on this island, Lord Howe Island. There's about 17,000 breeding pairs. Bycatch for this fishery is about 1,800 to 4,000 a year. This is where Lord Howe Island is. This is the South Island of New Zealand. Australia, Lord Howe Island's right here. You can see that these are satellite tags of flesh-footed shearwaters, so they're use quite a big area off of eastern Australia. And these are the threats to the species. So the threat to the eggs is rat predation and habitat loss through coastal development on the island. The chicks, it's rat predation and plastic in terms of ingestion of marine debris. And the juveniles, we know that it's the main mortality threats are probably rat and cat predation as well as fisheries bycatch, and the adults face both cat predation and bycatch. So this is a kind of a mitigation matrix, if you will, for the flesh-footed shearwater, and this was kind of what we threw out there and what we kind of guessed based on our best knowledge. When we have bycatch, you could do gear changes or you could close areas. They probably have a low effect or a high effect on the seabird, and then the relative magnitude of costs. We concentrated on bycatch, cat predation, and rabbidation because we had pretty good data, actually pretty decent data for those three mortality sources for the seabird. And these were a little unclear of the potential effect and the potential and the actual impact as well as the cost for mitigation. So our analysis only includes addressing these three potential conservation interventions. So option one was reduce bycatch by closures. You can see that the fishery worth somewhere around $30 to $70 million a year. The birds are most abundant in and around Lord Howe Island, but they overlap most of the fishery. And then option two was the eradication of non-native cats and non-native rats. We didn't have on-island data for flesh-footed shearwaters. There's a lot of data out there in terms of wholesale impacts on seabird colonies and cats. The best example is on Kerguelen Island. Cats have been shown to kill 1.2 million seabirds a year. And we had data on another shearwort population that Chris and I worked with another colleague, Brad Kitt, in Baja, California. So we were able to estimate bioenergetically the impact cats were probably having on the population. And this was a hypothetical analysis in the sense that cats were actually eradicated on the island in the 1980s, but we didn't have there wasn't any data attached to that eradication. And then rats, the same thing. There's currently a control program on the island. It's clear that rats impact seabird colonies worldwide. House mice are also present on the island, and studies have shown and documented the impact of shearwort populations on other islands that we were able to use. So this is basically the approach we undertook. We wanted to compare the cost effectiveness of fishery closures and eradication versus control programs for rats and cats. And we basically built a model. Chris built a model. And we looked at demographics, used a basic age structured model, population model, parameterized by real data, real observer data, and actual bycatch data. And like I mentioned before, we were able to estimate rat and cat consumption rates or predation rates bioenergetically with other empirical data that we worked with before on other shearwater populations. In terms of the economics, we did all this in a net present value, discounting 5% inflation, and we estimated the cost of the fisheries closure using a radial closure around Lord Howe based on observer and catch data to meet the mandated levels that are being proposed by the Australian government. And we used that value of the catch as the opportunity cost for shutting down the fisheries closure. And then luckily, actually, some New Zealand colleagues had already estimated the cost of the rat eradication. And we were able to, so the rat eradication costs were actually known by a previous study last year, and we were able to estimate the cat eradication costs with other cat eradications that our group has done over the past decade.
Can I ask a question about the economic measures?
Sure.
So the value of catch, did you deduct any of the costs associated with getting that catch?
I'm sorry, deducted?
It was just the gross value of the catch. Did you subtract any of the costs of getting the catch, so it's really more like a net profit measure to the fishing community?
Kirsten better answer that question.
So it was a little
bit. Is it
bit
net value or gross value?
It's a differential in the gross value. What we did was we assumed that it happens that the higher CPUE in that fishery is right around the island. So we basically displace the vessels. We build an individual model that displace the vessels from the closure area, but allow them to pick the highest CPUE available outside the closure. And so then we assumed that we didn't count travel costs would generally be larger for going to those areas, but we just basically left it at that, the differential in the CPUE, and then use that to calculate it through. So it's the gross revenue, but
you didn't set their costs for.
Yeah.
You're figuring that their costs are going to be roughly the same. So that's
exactly. That was the assumption.
Okay. So here are the results. On the y-axis is your conservation return. In this case, it's percent gain in the population growth rate. The x-axis is cost in millions of dollars. So a fishery closure is going to cost you $3 million, and you get about an 8% gain in your return in terms of seabird conservation. We also model the ongoing rat control operation on the island. This was actually a very interesting result that we didn't expect. Right now, Lord Howe Island, they spend $50,000 a year controlling rats. Turns out it's a complete waste of money in terms of control, because you can see basically you spend $1 million on control and you have no impact. And that's due to oversaturation of rats per density that are affecting the seabirds. And then you see if rat eradication costs $600,000 a one-time hit, and you get roughly an 18% gain in the conservation return, as well as the cat eradication costs quite a bit less, at least in retrospect, and you get about a 6% gain in lambda, or 7% gain. So this was a big light bulb that popped up on our head. We didn't expect such a drastic difference in terms of return for the rat eradication. So then we said, well, could we develop a framework in terms of transfer, since a $40 million fishery, which is killing 18 or 4,000 shearwaters, is actually equivalent to somewhere between 7 and 18 feral cats feeding on shearwaters on the island per year, or a closure. You can gain the same return by closing down the fishery than perhaps getting rid of the rats for $600,000. Is it possible to offset the bycatch by some other conservation intervention that has a higher bang for its buck? So in terms of potential compensatory mitigation for seabirds, it seems, at least in this case, it might not only be effective, but it also optimizes the situation both economically and biologically. Another potential advantage of looking at this problem in terms of bycatch fees is that it might pass on the true cost of the conservation and true cost of the impact, and it's feasible. It's feasible both sociopolitically and technically, which I'll return to in a sec. And then it's also enforceable in terms of, as long as you can have observer programs, or you can build statistical models that will predict the bycatch. And it's potentially sustainable in the sense that the user pays. So now I'm going to talk about why it might be feasible in terms of getting rats and cats off islands, as opposed to trying to shut down the fisheries. And that revolves around island conservation and the removal of invasive species from islands as a restoration tool, which I've spent most of my time doing over the past 10 years or so. So I'll just run you through some kind of case studies. This is one of my favorite ones. This is Clipperton Atoll. It's off the coast of Mexico. It's about 4 football fields. A seabird biologist by the name of Ken Stager went there in 1957 to study brown boobies. And he landed on the atoll in the middle of nowhere, and he found masked boobies, brown boobies, a whole bunch of land crabs, and pigs. Somehow pigs had got introduced onto Clipperton Atoll and basically wiped out the seabird colony. So in 1957, he showed up, instead of finding large seabird colonies, he found 55 pigs and less than 400 brown boobies. Luckily Ken Steger had a shotgun with him, and he shot all the pigs. And then his colleague went back, Bob Pittman went back in 2003 with 0 pigs, 112,000 masked boobies, 25,000 brown boobies. It's the second largest booby colony in the world. Wouldn't it be nice if all conservation was that easy, huh? Shotgun and a weekend on Clipperton Atoll. So a lot of people, particularly in New Zealand, Australia, and more recently in the U.S., have been spending their efforts trying to duplicate Stager's success. And over the past 20 years, we've gotten really good at it, or getting pretty good at it, in terms of if you look at the amount of islands worldwide that we've removed invasive species. We removed 49 islands, cats from 49 islands, rats from 332 islands, goats from 122, and worldwide invasive species have been removed from 629 islands. But the important point is that we're getting really good at getting them off large islands. The New Zealanders in 2002 eradicated Norway rats from Campbell Island, which is south of New Zealand here, which is 3 times larger than the Duke's campus. It was a big island, 11,000 hectares, and I've been involved in the Galapagos over the past 5 years, where this is the biggest eradication to date, where we removed goats from Isabella Island, which is 458,000 hectares, and that's bigger than Rhode Island. So these are massive efforts, and basically we've been able to leverage technology to remove invasive species from larger and larger islands, as well as doing it cheaper and cheaper in terms of cost effectiveness. So it's clear that we're getting very good, and we're getting much better year by year in terms of dealing with invasive species over islands. So what about in terms of the opportunities for compensatory mitigation for seabirds? And generally, if you look back at the IUCN data again, you look at the percentage of seabirds that are threatened both by fisheries, bycatch, and by invasive species, with an IUCN rating of critically endangered, endangered, or vulnerable. There's a pretty high percentage. Roughly more than half of the endangered seabirds are threatened both by bycatch and both by invasive species. So that at least suggests that it might be worth crunching some numbers and thinking about more creative ways of how you might be able to mitigate for bycatch indirectly. And then the question comes up, are there opportunities for sea turtles as well? Clearly, the mortality portfolio suggests there are. There's clear land-based impacts in terms of coastal development, non-native predators as well, and human harvesting. And of course, there's also these marine-based impacts. It might turn out to be a little more challenging because there's a large body of evidence, and which is Larry Crowder's work is fundamental in this, showing that adults are way more valuable in terms of the population and reproductive value than the hatchlings. And so that's going to go against at least the idea of trying to mitigate potentially from marine to land transfers. There's also a possibility to mitigate from marine to marine transfers. For example, looking at an industrial fishery and an artisanal fishery, where the industrial fishery is high revenue, the artisanal fishery might be having a higher impact, but they're not regulated. So compensatory mitigation, why do it? One reason is that it might be able to offer individuals incentives, which is becoming increasingly clear that that might be the best predictor of sustainability. It focuses on species persistence, and that it focuses on targeting the most important threats. It's potentially economically efficient. It's feasible. It may be applicable across different species and across political boundaries. And it might be a viable alternative when direct mechanisms don't work. But there's still a lot of unknowns, and that's what we're going to be spending the next year or two trying to answer. One is kind of the obvious, but shouldn't be overlooked, in that any reduction of at-sea mitigation will necessarily increase at-sea mortality. Now that's fine if you can lucratively offset that mortality on land for some species, say 10 to 1 or whatever the mitigation ratio needs to be. But it also could potentially increase the threat to other species that either lack a land-based stage or that intermingle with your target species at sea. Another issue is, well, how would we actually structure these transactions in terms of the accounting, the reporting, setting thresholds in terms of total allowable catch, and how to set those mitigation ratios in terms of how do we package or think about current impacts for future benefits, and obviously grappling and dealing with the uncertainty that involves around, that necessarily revolves around this process. And then there's clearly going to be some legal and policy challenges in terms of the Magnuson-Stevenson Act and how it intersects and interacts with the Endangered Species Act. And it also seems increasingly clear that this is not going to be a silver bullet by no means, and it's going to have to be approached from a system-by-system, species-by-species approach or basis. And that's all I have to say. So it'd be great to hear y'all's feedback, and we can also try to answer any questions you guys have if I wasn't clear enough.